Right, simplifying using fundamental trig identities. Now, if we're dealing with fundamental trig identities, what's the first thing that we need to have jotted down here? Well, I'd say that we need fundamental trig identities, so we got them there for reference. So let's jot them down. And now that we've got our first one, let's put down what our second one is. And what we said was kind of useful was that it would be useful to write down the other two variations on these. So we've got sine squared theta plus cos squared theta equals 1, and then we can just reference those other ones. So if we subtract sine squared, we'll have the cos squared one, and then if we subtract cos squared, we'll have the sine squared one. So let's jot down those two and put down the other one. And now that we've got both of those for reference that we can look at and see whenever we want to, let's use them. Okay, so 1 minus cos, I would never expect one of these to just be staring at you in the face to go, oh, it said sine squared plus cos squared. No. So we're going to have to do some work. Now we'd want to cancel some things at some stage. There's a square root. I must be honest, the square root makes me think there's going to be something squared later that we're going to square root that squared, but maybe not. Okay, so nothing jumps out. Maybe it'll be worthwhile just going, let's multiply. So multiply that. Now, I really do hope that you see that in the top, the minus cos theta will cancel with the cos theta. But if you didn't, you would have written minus cos theta plus cos theta in the next step, where I'm just going to write 1 minus cos squared theta all over cos theta. Okay, now hopefully, I wonder if 1 minus, is something here, does that look similar to any of these that we can see over here? I don't know. I mean, are there any? Yeah, I think we can see it, right? So we've got sine squared theta. That's the same as 1 minus cos squared theta. We still need to square root it and divide by cos theta. Well, the square root of something squared. Well, that's like saying, well, what's the square root of x squared? Well, modulus of x, perfect. So that's just the same as sine theta over cos theta. And we're done. No, we're not done. Because doesn't this look like one of our identities up here? Well, yeah, there it is. So you can say tan theta. Now there's a restriction on this that cos theta can't equal 0, but it doesn't ask explicitly for the restriction, so we don't need it. Okay, we'll move on to question B in the next video and have the same trig identities ready to go there.